Hello, everyone. Welcome to Life Edge, where life doesn't have to be mediocre. Joining me is our co-host and good friend, Dr. Susan Nash. Hey, Susan, how are you?
I'm great. Thrilled to be here.
Yeah, we've been down for about 3 weeks, 2 weeks down due to Microsoft, and we're back. Everything seems good again, fingers crossed, but all our tests have been good. So We have a great guest today. Let's play our intro and then let's get going. Here we go. And we are back. Susan, we've got a great guest today. Would you like to introduce him?
Absolutely. We have as our guest Brian Kalt of Fairmont Brine Processing, and they have a revolutionary new process for dealing with toxic and briny produced water from oil and gas wells. Brian, it's great to have you here.
It's good to be here. Thanks so much for taking the time to listen to Fairmont Brine Processing and what we're doing in the Appalachian Basin.
I have a question to get started. Could you explain to our audience, and our audience tends to be pretty general, what is the problem with water that comes from oil wells?
Sure. So typically a well, after it's been drilled and or fractured, that well will produce hydrocarbon and water for the life of the well. So the average lifespan of a well might be 30 to 40 years, and that well is going to produce hydrocarbon as well as the water that was used to drill and or hydraulically fracture that well. And that water is going to flow back up to the Earth's surface. So in addition to that water that was used in the process, the water that is also in the formation beneath the Earth's surface is also going to flow back up. And historically, that water has been dealt really one way. That's been sent back into underground injection, and you have to maintain sufficient pressure to keep that water back down in the Earth's formation. And what we have is an evaporation and crystallization process that's able to receive that wastewater, and we're able to recycle that through evaporation and crystallization, and we're able to produce distilled water, a sodium chloride, as well as a liquid calcium chloride.
So how much water are we talking about?
It depends which part of the country you're in. Thank you. It depends what part of the country you're in. Are you referring to our facility in particular, or are you referring to any play throughout the country?
Well, I know that in Oklahoma, for example, a well could produce, for every 1,000 barrels of fluid that's produced, 950 barrels could be
Sure.
water.
So the water cut is going to be different in every play throughout the country. Oklahoma, as you referenced, has a higher water cut, so maybe there are 8 barrels of water for every 1 barrel of oil that are produced.
Right. And so how exactly, how much are we talking about? Is, for example, the water that you process, how much can you do a day?
Well, the facility we have in the Appalachian Basin is a smaller scale facility. It has the ability to receive up to 15,000 barrels a day. Somewhere in Oklahoma where they're disposing of 500,000 to 1 million barrels a day, obviously that facility isn't built to accommodate their needs. However, this process can be built to accommodate that with proper planning.
Really? So with proper planning, you can handle 1 million barrels, which is 40 million gallons, 40 million gallons a day?
Well, there'd have to be multiple facilities, or there would be a number of facilities in one large complex on one property. But the process is capable of handling those volumes on a daily basis.
That's amazing.
So evaporation has been going on since the dawn of time, so nothing fancy there. Crystallization's been going on since the 1800s, but utilizing evaporation and crystallization as a treatment method for the wastewater produced in the natural resource extraction process is relatively new. As a matter of fact, there's really no one else out there in the world that's doing it.
So what happens to the water after it's been processed?
After water has gone through the evaporation and crystallization portion of the process, you're left with three products. You're left with a distilled water. That distilled water is reused in the drilling and fracturing process. We're also permitted under a National Pollutant Discharge Elimination System permit to discharge that into a waterway.
Okay.
So if that water is not being reused in the drilling and fracturing process, that water would be discharged into the river. We also produce a dry sodium chloride rock salt, and that all gets reused on the roads throughout the winter time. It's also used in the chemical manufacturing industry. And thirdly, we produce a liquid calcium chloride. We can get up to 10.8 pounds per gallon with about 30% calcium concentration, and that gets reused in the drilling and fracturing process as well.
That's pretty fascinating. So it's quite a bit of recycling going on.
Yes.
How much does it cost?
The cost varies depending on the length of commitment and the volume that an exploration and production company would bring to the facility on a daily basis.
So how the evaporation and the crystallization, I know they can occur naturally just over time, but do you do anything to accelerate the process by using heating or any kind of electricity?
We are. It's a multi-effect evaporation and crystallization process, and there's a natural gas-fired boiler that's accelerating that process. So when I say evaporation, it's not a evaporation pond that you may be used to seeing out there on the the Delaware Basin, etc. And when I say crystallization, it's not fluid sitting in those ponds collecting crystals.
Oh, that's interesting. So when it does that and you accelerate the process, it sounds like you can produce it pretty quickly and you have process it quickly.
We can. We produce about 100. It depends. The concentration of the incoming fluid is never uniform, so that poses some challenges. But when you're firing on all cylinders, you should be producing around 100 tons of dry sodium chloride a day.
And also, when you use the gas, you can use produced gas for that, right? So you can use the same well that's producing some oil and some gas and some water. You can just separate out the gas and use that right there on the lead.
So that's how we start to get creative and figure out how to start chipping away at that treatment fee. Right now, we don't do that. We do not receive natural gas from any producing wells that we're receiving water from. However, for us to get into Oklahoma and be able to compete with the cost there, that is something we would seek. We would look to be we'd look to receive natural gas from one of the operators that we were receiving fluid from.
That's good. Go ahead, Rick.
I was just wondering, Brian, how did you get into this business?
Well, I was in Texas for quite some time with a company that was doing recycle for reuse at the wellhead, and I think recycling for reuse is great. I think it has its purpose. However, I think at a certain point in time, that is no longer an option, and that's what I started to see, that there were companies that could recycle, flow back and produce fluid for reuse and in future completions, and they were a dime a dozen, and they all pretty much did the same thing. However, I didn't see anything out there that was going to solve a problem when you weren't going to drill and fracture that next well. So I thought at the time that this was a little premature to come up and do this, but I took a gamble with it, and I think over time it becomes more special. And I think we would all recognize that over the past several months there's been an uptick in the media's coverage with technically enhanced induced seismicity. And I think this is starting to become a little more special.
Yeah, that's fascinating. Is your background in petroleum and engineering?
No, my background is public relations.
Okay.
Oh, that's great.
Great.
I think that's really good because I think that you can always get the technical specialists, but it really takes that kind of understanding of how to get the word out to get adoption. And here in Oklahoma, as you pointed out, induced seismicity has really become a problem. You've met with people in Oklahoma, right? What were their reactions?
It's probably going to be a slow process. We have spoken with a number of different groups in Oklahoma, exploration and production companies, as well as regulatory bodies. And while it's acknowledged that there's a problem, there's still the issue of what is it going to cost to make a change.
That's a problem at $30 barrel oil.
It is a problem at $30 barrel oil. I think we can compete now with the cost of deep well injection, and constructing a facility this magnitude in Oklahoma in particular, you're looking at 3 years, and we don't need any capital from an exploration and production company. We need a commitment from that exploration and production company to utilize this facility for a minimum of 5 years. Once we get that commitment, we're prepared to start this endeavor. So once we start, you're looking at 3 years before you're up and running. I think we'd all acknowledge that in 3 years, the price of oil will not be $30.
Great. Can you commercialize the distilled water?
There are a number of hurdles you have to jump through to do that. I think depends where you're at in the country. You'd look at what you'd use that distilled water for. In Texas, Oklahoma, New Mexico, obviously, where it's a struggle to keep a frac going almost on a daily basis, you want to feed those fracs with the distilled water. We feel like it reduces your biocide, your scale inhibitor, and your friction reducer downhole. So we feel like in addition to reducing the overall chemicals that you're putting downhole, you're also saving money at the wellhead, and that's a plus. But we also think that the distilled water will be probably better served for agriculture.
I'd like to see you guys explore the possibility of using the produced and processed distilled water for revitalizing wells that are about to be shut in.
I think that's an excellent idea. I mean, and again, it depends where you're at in the country. A lot of people are, and I certainly was before I came here. I mean, I spent a number of years in a number of different states doing water management, and it was such a struggle to have water on a daily basis. And, to come up here and see how they have access, they as the Appalachian Basin, Pennsylvania, West Virginia, Ohio, has access to so much water, fresh water on a daily basis. They're really spoiled, and a lot of people haven't been in other parts of the country and felt the pain of what it's like to worry about where you're going to get water to keep your operation going.
And they haven't experienced droughts like California.
Not at all.
Yeah, I say because we're in California. It's dry. It's really dry. Not like it, we're in Southern California, so we feel that all the time. Brian, and actually Susan, both of you on this one, what do you see the future of oil being? Will it be more drilling? Will it be more fracking? Will they figure out how to make fracking, I guess, safer, more productive, and everything else? What do you see as coming down the pipe, if you will, no pun intended?
Nobody wants to answer this.
I mean, I'll jump in there. I mean, we can start from a safer standpoint. I feel like the industry is using the best practices available. I think the industry's come a long way. I think if you spoke with industry veterans, they would tell you that we're getting out of the ground the best we can, and we're doing it in the safest manner we can. There have been issues along the way, but I think everyone would acknowledge that those issues are fewer and far between. So I do believe that all exploration and production companies are going about this in the safest manner possible. What do I see from a production standpoint? I think that we have some of the best technology out there to continue to extract hydrocarbon from beneath the Earth's surface, and I think that's only going to get better.
I totally agree with that, and I would add one more, that I think that we have to use technologies like yours, Brian, in order to maintain production, because our existing methods of disposing of the produced water are not adequate, and they also preclude the use of new technology, say using surfactants in transition zone dewatering, for example. And those are new technologies we'll have to use to get the 60 to 70% that's left behind in the old fields.
Yeah, I mean, I don't think a lot of people realize the hindrance that this water has the ability to cause. You know, if the drilling and fracturing process were to come to a screeching halt tomorrow, there would not be enough available capacity in all of the deep well injection facilities throughout the country to accommodate what stands to be produced throughout all of the major basins in this country. When these wells have the ability to produce for the next 40 some odd years, in addition to hydrocarbon, those wells also produce water. So, you know, whether you continue to put that back down hole and maintain pressure on it and continue to cause induced seismicity, or you can find alternatives that can replace the old method for disposing of this wastewater.
I personally think it's a big way. It's a tragedy too to re-inject water that could be potentially used for something else, and also those additional minerals that are not just chlorides, but they're also some other useful minerals that can be used.
Well, Susan, what would you consider a replacement for water, especially in the fracking process where the pressures cause the seismicity?
Well, let me just weigh in on that. So I think behind closed doors, industry veterans would tell you that it is not the drilling and hydraulic fracturing process that's causing induced seismicity, but rather it's the sequestering of trillions of gallons of wastewater beneath the Earth's surface and maintaining sufficient pressure to keep it there that's actually causing the induced seismicity.
Mm-hmm.
So
Absolutely.
Okay.
Yeah, totally on board with that. But to get back to the issue of the public's fear of hydraulic fracturing, you have to have something that cracks open the rock. And so people have experimented with gas, but different types of gases. But that's actually that has its own issues as well. And you still are going to have produced water because the water is in with the oil.
Correct.
Have they ever used sound to fracture the rock?
Yes.
Yes? Wasn't as effective?
No. Well, they can do it, but they're tiny, tiny fractures.
Because, you know, they have some sound weapons that they can knock down buildings, but of course that's different, and it's traveling over distance versus small areas.
Yeah, I don't think that the actual fracturing of the formation is the issue. While you do fracture the formation to cause the fissures, that is simply to allow hydrocarbon to flow back to the Earth's surface freely. You're not, once you've drilled and once you've hydraulically fractured that well, you're not maintaining pressure on that well. You've fractured the formation and now you've allowed hydrocarbon to flow to the Earth's surface freely, as opposed to the deep injection of this wastewater where you have to continuously maintain pressure to keep pumping that water back down into the formation.
Back to the idea of using sound, frankly, I find that terrifying to have sound waves that big and that resonating. It makes me think of Dorothy Sayers and some of the Nine Tailors and the people who their skulls ruptured or something ruptured by being, eardrums ruptured by being too close to bells. Anyway, random thought.
Well, I don't think you want to be near it when it's doing that, but
Unintended consequences, Rick.
That's
There
true.
could always be those things.
that's true.
But we could have Microsoft do it so
Gosh.
nothing would go wrong.
You'd have worse seismic activity.
It's been really great to have you on the show, Brian. I think this is so important and very timely. I really agree. I like what you're doing.
And I think it also sheds light a little bit on some of the processes that go on with oil and fracking. A lot of people just think it's, drill, you get oil, you're done, and the Beverly Hillbillies show up. It's very different.
I think those days are over.
That's right. And it is fascinating, all the work that's being done in the area. and I love the kind of work that you're doing, because it's really even more fascinating the results of what you get and the products that you get from it, it's pretty good. So you are reusing a lot of it. And so you just see in the future the water part of it probably being the most challenging, but yet probably the most lucrative in a certain way as things move forward.
Oh, certainly. The water is definitely the biggest issue of this, and it's a multi-billion. It is now, and will continue to grow. It's a multi-billion-dollar a year industry.
Yeah, I wish you could recycle some of that water and send it to California, because we're not run well. We need
Rick,
water.
I have a map on my wall right here. I am ready to come to the Monterey Basin anytime.
That would be great. That would be great. We need people like you. Solutions. That's what we need. Solutions.
Yes. So, final question, Brian. What do you believe has given you an edge in life?
Me personally?
Yes.
Oh, I don't think I have an edge in particular. I think I'm just an average guy.
Well, here's what I think, just after listening to you, and I tied it with what Rick was saying. I think that one of the things that inspires me about you is your solution-centered approach to life.
And one thing, only knowing you for a couple of minutes, a guy who came from public relations, who understands the nuances of pretty high technology and applying it in a way that makes a lot of sense. So I'd say that's a pretty good edge.
Oh, yeah.
Well, I mean, it was certainly exciting to be a part of a solution.
Mm-hmm.
I could have been quite comfortable where I was in Texas and continued on the path of recycling for reuse, which again, I think is great. However, I just feel like at some point you're going to have to be prepared to face a real issue. And the issue that is being talked about behind closed doors is, how do we responsibly manage the wastewater produced in the natural resource extraction process? And there are only so many options to do that. One of them is deep well injection, and that is something that works in some parts of the country, but it doesn't work everywhere. And other than that, there's evaporation and crystallization.
Brian, if somebody wants to get a hold of you or find out more about your company and your processes, what is the best way to reach you?
I think if anyone wanted to get a hold of me, they'd be more than welcome to send me an email, and maybe we can put that up on the screen or get it on the whatever site this goes on to. But my email address is bkalt, as in Texas, at fairmontbrine.com.
Okay. And we'll put that up on the show notes.
Definitely.
That sounds great. Well, Brian, it's been a real pleasure having you on. We wish you the best of luck with the business and really good growth, because you're in a really good, I think you're in a good place, and something that we need to help the industry move forward and deal with part of what comes of the industry. So this is very good thing, a very good thing.
I totally agree with that, and just really want to thank you, Brian.
Well, thank you both so much for letting me come on here and tell you a little bit about what Fairmont Brine Processing was doing.
Yeah, we're more than happy you could come on, and we appreciate you coming on. And we will have this show up a little bit later on YouTube. If you're watching the show, please subscribe. Let us know what you think. And you can get a hold of Brian at the email later on in the show notes. Have a good one, everybody. Thanks a lot, Brian, for coming
so
on.
much.
Susan,
Bye.
until next week.
Thank you.
Bye-bye, everybody.
Great job, Brian.
What's with that question? What's my competitive edge? It's the one-arm push-ups I do every